Future missions to Mars, like the one planned by NASA for 2020, have a high chance of finding microbial life, according to Professor Brian Cox. The physicist, best known for presenting Stargazing Live and Wonders of the Universe, says that these organisms may be more common than we might think in our solar system. Civilizations are another matter, he believes, and it may still be the case that we are alone in the universe as its only advanced intelligence. Finding evidence of life on Mars will almost certainly involve a rover, and scientists admit it will be tough. Astrobiologists likely will need to decode the chemical analysis of rock samples performed by a rover like the one NASA plans to send to Mars in 2020. The new lander will be equipped with 2 solar panels, which unfold like paper fans for a total width of about 20 feet, 6 meters. After landing, its robotic arm will inject its 2 main instruments into the Martian surface. A seismometer sensitive enough to detect movement half the diameter of a hydrogen atom will record seismic waves from marsquakes and meteor impacts. If we went to Europa, and went to Enceladus, and went to Mars, and had a good look, I wouldn't be surprised if in one or more of those places you find microbes. But whether that life becomes multicellular and ultimately intelligent is an entirely different question. It's quite possible that civilizations are very rare. Professor Cox argues that the search for life in the universe, and our place in it, is a deeply profound one. The University of Manchester faculty member says that coming to view our planet as unique is a vital step in our political development. Is valuing Earth as a rare, or even one-off place where complex life forms have been able to evolve could help to unite us. He added, let's imagine that we start to come to the view that there are very few places like Earth with a civilization on it. I think that's a necessary step in our political evolution, because at some point we've got to find some direction, some way of running this world that is not fragmented. Whether Martian life has ever existed is still unknown, as no compelling evidence for it has been found. When Curiosity landed in Mars Gale Crater in 2012, the mission's main goal was to determine whether the area ever offered a habitable environment, which has since been confirmed. Evidence of water on Mars dates back to the Mariner 9 mission, which arrived in 1971. finding signs of life will almost certainly involve a rover, and scientists admit it will be tough. Astrobiologists likely will need to decode the chemical analysis of rock samples performed by a rover like the one NASA plans to send to Mars in 2020. It revealed clues of water erosion in riverbeds and canyons as well as weather fronts and fogs. Viking orbiters that followed caused a revolution in our ideas about water on Mars by showing how floods broke through dams and carved deep valleys. Mars is currently in the middle of an ice age, and scientists previously believed liquid water could not exist on its surface. Evidence of water on Mars dates back to the Mariner 9 mission, which arrived in 1971. This image from NASA's Mars Reconnaissance Orbiter shows what could be erosion by water. In June 2013, Curiosity found powerful evidence that water good enough to drink once flowed on Mars. In September of the same year, the first scoop of soil analyzed by Curiosity revealed that fine materials on the surface of the planet contained 2% water by weight. Last month, scientists provided the best estimates for water on Mars, claiming it once had more liquid H2O than the Arctic Ocean, and the planet kept these oceans for more than 1.5 billion years. The new lander will be equipped with 2 solar panels, which unfold like paper fans for a total width of about 20 feet, 6 meters. After landing, its robotic arm will inject its 2 main instruments into the Martian surface. These, NASA says, will become permanent fixtures in the ground. A seismometer sensitive enough to detect movement half the diameter of a hydrogen atom will record seismic waves from marsquakes and meteor impacts. And a He probe placed more than 10 feet, 3 meters, beneath the surface will record energy coming from the planet's deep interior. They say if there was life on the red planet, it probably will present itself as fossilized bacteria. MASTCOM-Z, an advanced camera system with panoramic and stereoscopic imaging capability with the ability to zoom. The instrument will also establish the minerals found in Mars' surface and help with rover operations. SuperCam, an instrument that provides imaging, chemical composition analysis, and mineralogy. It will also be able to locate organic compounds in rocks from a distance. Planetary instrument for X-ray lithochemistry, PIXL. an X-ray fluorescence spectrometer with a built-in high-resolution imager, then can determine the fine-scale elemental composition of Martian surface materials. PIXL will make it possible to make detailed detection and analysis of chemical elements than ever before. Scanning habitable environments with Raman and luminescence for organics and chemicals, Sherlock, a spectrometer that offers fine-scale imaging and uses an ultraviolet (UV) laser to detect minerals and compounds. The rover will have a spectrometer that offers fine-scale imaging and uses an ultraviolet (UV) laser to detect minerals and compounds. The Mars Oxygen ISRO experiment, MOXIE, an exploration technology that will produce oxygen from carbon dioxide in the Martian atmosphere. Mars Environmental Dynamics Analyzer, MEDA, a set of sensors that provide measurements of temperature, wind speed and direction, pressure, relative humidity and dust size and shape.